In this video, I'm going to create a button box, a flight sim peripheral that I can use to fly and program knobs and switches. I'm going to show you how I design it, how to build it. If you're interested in this kind of thing, you might want to check it out. And I'm going to design what I'm building on the A-10C from DCS. I'm going to build the radio stack. Down here, the 3 radios. I'm going to build a box that has all of the knobs that you would use, buttons, most regularly, and I'm going to leave out things that I don't use. I'm not going to make a one-to-one cockpit panel. That would require a lot of inputs. I'm going to play in VR, so I'm not looking to create like every knob and switch. I just want the ones I need to use all the time, because I'm not building like an actual cockpit. I just have like things I clip to my desk, and I want to be able to access the radios quickly. So let me show you how I'm going to do this. First of all, here is the radio stack. So in this panel, I don't use a lot of these extra buttons. I use the control knobs, I use the radio frequencies. There's a few buttons that I use. So that's what I'm going to program in. I'm going to buy a Bodnar BBI-64. So that means it has 64 inputs. I can hit a switch, have 64 different things programmed. The other option is to use DCS BIOS, and then that would allow you to basically program every single one of these switches and make it specific to your device. But I want it to be more generic. So when I plug this controller in, I want it to show up in Windows as just a USB controller, and then I'll go into the game and bind every button and switch to it. That way I'm not putting in any kind of programming code or any of that kind of thing in an Arduino for a board, and having to do all that. So I think it's useful this way, because then I can use it for any other module. I'm going to lay it out and probably only use it for the A-10C, but who knows? Most radio frequency stacks are going to be similar to this. Maybe I'll end up doing that. So the first thing I did was I just went and looked. I had a whole bunch of knobs and switches and stuff from building other things. So I decided, here's what I'm going to use. I found like different types of knobs to use for the different frequencies. That way I can, when I'm in VR, feel for it and like, oh, that's this one. I think in the end it turned out that they're spread out far enough that my hand knows where to go by muscle memory. I could have used the same knobs, but I think it worked out to have different types of knobs for each radio. These low flat knobs are the control knobs. They're a little lower and wider, and then the taller, skinnier ones are the ones that are all these, frequency knobs. The buttons, these are buttons, like that button's going to be for this I use all the time. That button's going to be for the AM FM, because the game decides to put it in FM without me switching it. Somewhere in the 140 range, it always goes to FM and I have to put it back. So I use that button all the time. The one thing that's difficult with the rotary knobs, since I'm going to have 64 inputs, is like there's not going to be room for all of these, And if there was, I would need a rotary switch that had 1, 2, 3, 4, 5, 6, 7 positions. So I don't use most of these other positions. I use turn it off, which I could honestly, you could not even program off if you wanted to. But I use transmit and guard, change preset, and off. So every rotary knob gives me 3 options. I can turn it left, turn it right, or click it. So I don't really need any more than 3 on each of these. So I'll show you how I program that later on. But it would be nice if the A-10C module had the increase decrease for this knob and this knob. The control knobs, they don't. They have it for the frequencies increase and decrease, but they don't have it for these knobs. You have to give it like a specific spot. So I don't know if anyone's listening out there in the DCS programming world. I'd love to be able to just be like, UHF, VHF radio increase knob 1, and that way I could have all of them. But I'm going to program it specifically. So now that I have the layout that I wanted, I went ahead and got a piece of cardstock, cut it to size. In fact, I had to actually tape 2 together, because I think this is 17 inches tall, and this is, I believe it was 8 inches wide. And I just made sure it was going to fit the way I wanted. So this will be the size of the top panel that I build. And so then I traced out, grabbed my ruler, traced out a design here. I needed to leave a border. I'm going to build this out of wood as the frame, and then a piece of ABS plastic, which is only an 1/8 inch thick, to hold all the buttons and switches. But I just have trim wood laying around the house. I have tools to work with wood. I don't have a 3D printer, so I'm going to go ahead and build it like this. It's the way I build all my things, and it works out great. So I had to leave the border for the frame that will go around, and then I just fit all the buttons in there, and it ended up being this size. Everything's centered and spaced out, so when the buttons pop in there, this is the way it will end up being. You can see that's a rocker switch for this left and right control right here. Yeah, so let me show you how I'm going to do it. So I bought a piece of ABS plastic. It's just an 1/8 of an inch thick. I got it on Amazon. I don't remember the exact size, but if you just look for ABS plastic, it's got textured side for one and then a smooth side. The smooth side always has a bunch of, like, you can see it has like streaks and so forth, and I always use the textured side as the size you see, and I just went ahead and grabbed it, put it on the table saw and cut it to size. So here I just grabbed some scrap trim wood. This actually was the frame of like a chalkboard or something that I had in one of my kids' rooms, and I just was like, this will work. I just need some pieces, so I cut the 4 pieces that I would need, and I'm going to make this becomes the frame that I'll put the piece of ABS plastic on. That basically will house all the wires and the Leo Bodnar board inside. So just making sure that it's going to be a nice balanced rectangle, making each cut here. I brought the wood over to a workbench, grabbed my clamps, and I'm just going to use some wood screws to attach the frame, 2 per connection over here. I put them, at the bottom and then kind of a little bit above the middle, leaving spot at the top where the panel is going to screw down in. I don't want the screws from the panel going down into the edge of the wood to hit the ones that I have going in crossways. But I just kept this really simple, squared them up, did them by hand, didn't do anything crazy with pocket holes or so forth. I just need a good frame. It's lightweight, and so you can see I just use 8 screws, and then I'll grab the panel I cut. Should be perfectly fit to the sizing. It's measured it all out, and then the template will go on top, and I will get the pilot holes ready. Now as I'm about to screw this thing down into the panel, you can see I made sure my screws would not touch the ones that I put in. I made sure I drilled them low enough that they wouldn't get in the way. I definitely drilled pilot holes. My bit there has the little countersink piece to it. That way the screws will sit nice and flush in the panel. And I measured it out, spaced it out. I think I ended up putting in more screws than just this one, but for now that's all I needed to get started. Get it all centered up. So you got it all attached, make sure it was good to go, and I'm going to go ahead and drill the pilot holes ahead of time. So you can see I sand off the edges, just round everything off a little bit so there's no sharp edges against my hand. Just took a sanding block basically and rolled them over, and then I taped down the template that I made using some blue tape, painter's tape, get it in place, because I'm going to drill pilot holes for everything based off the template. So I'm going to use Forstner bits to do these holes, like the actual holes. So I'm just taking a really tiny drill bit and I am drilling the center of each. A Forstner bit is basically meant to drill a nice clean circle. It has a center point, so this pilot hole will actually be where the center of the bit goes. That way I know everything is going to be nice and clean. You can see the little square, the rectangle at the bottom, that's for the rocker switch, so that one I'll have to cut by hand. I'll show you that too, but I'm basically just doing a tiny little hole, a pilot hole for each one, then I'll take the template off and drill the actual holes in the plastic. So here are the buttons and the rotaries that I'm using to make the panel. I have another video about all the different types of buttons and rotaries that are available. And then those are the Forstner bits, but I'm going to go ahead and test fit to make sure that the holes that I drill are the right size. Most of these buttons and knobs are in metric, so I'll take a caliper and just measure. So I have some metric bits, but not all. And I'm going to make sure that the hole that I drill actually fits. But you can see how nicely the Forstner bit creates a perfect circle, nice and clean. It has a center point when you give it that pilot hole, so you know it's going to be exactly in the right spot. I don't have to worry about an old, like a standard drill bit shifting at all in the plastic. And I just make sure everything fits before I move forward on actually cutting them in the panel. The Forstner bit for the rotary dials was a little too small, so you can see I go back with a regular drill bit and widen the hole, but since the hole's already there, I know everything's centered and I don't have to worry about it shifting and being off center. Once I have my drill bit sizes for each button, then I just go ahead and start drilling them through there. I know it's hard to see in this video, like you can't see that the pilot holes are there, but you saw I already drilled them through the template, so I'm just putting the Forstner bit right in that little spot there in the little pilot hole, and it keeps it centered and puts everything exactly the way I laid them out. And obviously you'll see me go back afterwards with the other drill bit and widen the holes for the rotaries because that one's not quite big enough, but the Forstner bit is perfect for getting everything centered up squared so you don't have any crooked rows of buttons. You can also see as I drill that there's a little bit of flex to the plastic. I ended up going back later and putting in small pieces of supports like between each of the 3 radios. That way it would be nice and firm. I wouldn't have any flex in the plastic. I don't think I have that on video, but you'll see it from the other side once we start wiring. Cutting the rectangle for the drop in there of the rocker is kind of a pain. I just used a razor blade basically, but I had the 4 pilot holes to kind of guide me. I went over a little right there. I was really annoyed by that. But you just have to take it slow. This took a while. It's kind of a hassle trying to cut your finger open, but you just slowly work your way through it. I mean, the ABS plastic's an 1/8 inch thick. It's not too tough, but it's kind of a hassle. I'm not going to lie, but just take some time. You'll get the hole through. Halfway through the job, I ended up swapping razor blades. That other one kept like getting recessed, so I don't know. This one made it a little easier. So had to go back and tweak the size of the hole a little bit because it didn't quite fit. But that's probably better that way. I know it's nice and tight once I get it in there, not too big. I spray painted it black and then went ahead and put the panel back on, and I flipped it over to figure out exactly where the BBI-64 would go. So this is the board right here. That's it, a BBI-64. It's got 64 inputs, and I'm like, I made sure that I made the side panel wide enough that it would fit on the side. I'm just going to stick it on there and cut a hole for the wire to go through. Cutting the hole got a little sloppy. I figured I was going to just do the drill bit there and then take a wood chisel, but obviously I didn't think about the fact that it was going to be that tiny piece on the corner and it chipped, so I went back and glued it back in so it would kind of be presentable once it was done. But you got to be real delicate. I'm like, I don't know what I was thinking. I should have gone right to the edge of the box and not worried about moving it in a little, but oh well. So now we get to the soldering. And this is the rotary switch, which is really difficult to solder because it has these tiny little pins, but it can go to the left, to the right, or you can click. So there's different ways to wire them. You'll see the side with the 3 there, that's the rotary. The center one is ground, and then the left and right are like to turn to the left, to turn to the right. And then this side is the button. There's ground and then click. So they're really small things to solder, and I'm not a soldering professional by any means. I'm not an electrician, but I, just trial and error. By the time I was done doing this thing, I got really good at soldering them, but just using a pair of helping hands right here, get it lined up, and then I have these cords here that'll pop right onto the prongs of the BBI-64. They just slide right on there. Nice and simple. One row is the actual input, and the other row is the ground. So I basically use those pre-made ones, and I clipped the end, wire stripped it, and then took that tiny piece of wire and very tediously soldered them onto each little arm of all of the rotaries. I had a bunch of them. I moved the camera because I thought this was a better perspective to be able to see, but there is one of the wires there, and you just gotta, like, each one has to go up against the prongs there. So here's my attempt. This is one of my early attempts at getting it on there. But I found if I put a little solder on the wire first, got it on there, then I just kind of go back and reheat it. But there's shrink wrap as well that I used on each connection to kind of protect it. So I cut those to size. Got to make sure you remember to slide those on first, and then I would go back and slide it up over the connection, and it would kind of protect it and keep it secure from touching any other ones. So here we go. One of the trickiest things with the wires were so lightweight, such a small gauge, that I had a hard time just getting them lined up to sit in the right spot to be able to do the solder. So you can see I put a little solder on first on the tip of the soldering iron, and then kind of that got it ready, and then just hold it in place. I didn't get the first try. I got really good at this by the time I was done, but there we go. Oh, 3 tries for this one, it looks like. There we go. And it's just too sloppy for me, so I'm just trying to make sure I get it in the right spot there. There we go. That's it. So here's where I put the heat shrink on. You can see I slid it up over the connection. You have to make sure you put it on first and slide them up over the connection, and then just grab a heat gun. And I felt like that would secure the connection and make it look good. So there you go. So here's the toggle switch. These were much easier to solder. You can see how big of a surface you have. So I just went ahead and threaded kind of a longer piece of the wire through the hole, kind of looped it, flattened it down, and then took the soldering iron and put the solder on. It was a piece of cake. The 3 standard buttons I put in had these little screw downs, so I was like, oh, I'm going to take the ends of these and just screw down the pins, which worked great except for one. There was one of them that had a bad connection. I ended up taking them out. It was only 6 more soldering points. I took the screws out and ended up just soldering them in. I don't have that on video, but I was hoping that would work. But there was apparently those little plastic ends. They pop off kind of easy, so I did have to actually solder them into the holes. It's not a bad step to go ahead and check the continuity of your connections to make sure like your soldering skills were good enough to make the electricity pass through. So you can see I have my meter set to the continuity, and you just put it on both of them, and when you depress the button you should get the tone and it should zero out, or for the most part zero out. Then you know your connection is good. You can see from the flex that I had when we were drilling, I put those supports in there to keep it nice and firm. But now it's time to go ahead and exactly figure out where the board is going to go, and then I need to start wiring up, or I'm sorry, attaching the buttons and rotaries. So I was like, I'm going to start where I'm going to put the boards, that way I can get those in first, and then I'll attach the wires the rest of the way. But this is a rotary knob, so I put it through there. It comes with a washer. I ended up not even using the washers. I just put the nuts right on there, and grab a screwdriver or a wrench, and make sure they're tight enough. The wires are sticking out there, and so I put these ones in that I knew were going to be right near the board first. That way they wouldn't be in the way. Yeah, I could get the board in place and then put the rest in. So here you'll see this rotary knob. I didn't have to do all the soldering points. This has only got 3 wires because that's just the rotate left, rotate right, and ground. This one I wasn't going to use the push feature, which saves me some spots on the board. So it's just 3 cords. So here's the way the connections happen in the board. Since it's a rotary knob, I know, because I've used these boards before, that you have to make sure you put the first rotary left or right on an odd number button, and then the next one on the even right after it, just the way the software works. You'll see there's 2 rows here of pins. So every row, every pair there, it says like B1, so that's button 1, and then it's ground. So the outside row is the ground, and the inside row is actually the button. So when I go to put this in here, I know this is a rotary knob, so I have to start on an odd number. It looks like I'm putting it on number 9, I believe, is where I went with this one. So the center one is ground, so I'm going to put the ground on there. You could actually put the ground on any pin, it wouldn't matter. They're all interconnected. But then the first rotate goes on the odd number, like number 9, and then the second one would be the one immediately after it. So I put that one on 9, I put the other rotary on 10, and I'll be good to go. All rotary knobs have to start on an odd number, then an even, because of the software. So that was a rotary. This is just a standard button. So press just triggers 1. That means in the board you're going to basically choose which number you're putting it in. 1 goes in the ground, 1 goes in the button. Simple. I was trying to be a little strategic here. This is the center stack of radio. Trying to make sure I put them all in one location. So I kind of started from the top of the board and worked my way over. That would leave plenty of room to bring in everything from the FM radio there, maybe to that part of the board, and then I could take everything from the upper radio and use those 2 sides of the board. All the wires would reach, and I'd be able to manage the cables. So you can see as I started the upper radio stack, I went ahead and filled in the rest of the bottom half of the board, and then I knew that I had room for everything else from the top edge. And so now that the bottom part was finished, I went ahead and just used some Gorilla Tape. Actually used 2 pieces of Gorilla Tape, so it will be thick enough. Those pins stick down through, but 2 pieces, one attached to the other, made it thick enough, and that stuff is strong. That's the heavy duty stuff, and I just went ahead and stuck it on there. Nice and simple. I know from experience that stuff is not going to let go, and it was very secure. Now the top panel is completed. Everything's wired in to the right side of the board there, and time to move on to the bottom, which I put those on the final left bottom part here. You can see I have some leftovers. There's an example of rotary without the switch, and then rotary with the button switch. So one of them has 3 coming off, the other one has 5. And you can see the rotaries. You can see all the gaps there, spots that are skipped because they use 2. I went ahead and put all the knobs on. It was easy, just pop them on there. So they kind of just slide on. It's pretty simple. Some of them have a set screw, like this kind here. So put that on there and put the set screw. And then some of them, like these rotary knobs, you just pop them on there. They can be a little tight, but they just kind of slide right on there. Oh. Yeah, they can be a little tricky, but they just slide right on there. All right, so we're almost finished wiring everything up. Just got to put the toggle switch in, which is super simple. Pops right into place. And you'll see there on the left, on the side of it, I put the single, double, and then triple like bumper pads like you use for your kitchen cabinets or whatever to stop the door from banging. That way when I reached down I could feel where I was, top, middle, or bottom. See those there? And then I went ahead and did some cable management, put some twist ties just to make sure everything was going to stay in place. The bottom panel that I put on it, I use this like grip tape because I'm basically sitting it next to my chair. I was going to try to attach it to my chair, but it didn't work out, so I'm just putting it on top of something. So I put that grip tape on the bottom, which would keep it from shifting around while I was using it. All right, here we are on the computer. Let me plug in the device. And let's make sure it's there in Windows, USB game controllers. Here we go. There's our BBI-64 device plugged in. The problem with using this is that it only goes up to 32 buttons, and we have up to 64 possible on our board, so this isn't going to be useful for us, so we'll use this button tester software I got from VKB, because I have a VKB controller. So, it goes up to 128 on this. Just make sure you actually choose the right device if you have other things installed, or plugged in, I should say, like another joystick or throttle, whatever. It'll show up here, so choose the right one. I'm just going to turn the log off because that gets to be a little much in explaining things. But either way, now if I push a button, I should say, there you go. You can see the buttons are pressed. If I push down the rotary knob buttons, there we go, because I wired many of my rotaries with the button as well. Make sure everything is working. And then you have to program in your rotary knobs, because if you just rotate a knob now, see how I'm rotating a knob and I'm getting 37 and 38. This rotary knob's plugged into spot 37 and 38. But if I just go one direction, you can see, like I'm going to the 38 direction, you can still see 37 lighting up, and vice versa if I go the other way. So you have to use the config software from Leo Bodner's website, BBI-64 here, and when that loads up, it will now allow you to choose which spots on the board you plugged in a rotary knob. All right, so it gets a little weird over here with the screen recording. This thing gets not responding. It'll come around by the time I'm ready for it. Either way, this is why when we were wiring up the board and we did a rotary knob, I said you have to make sure that you start the first rotary knob signal into an odd followed by the even right after it, because when you go to choose the rotary knobs, that's the way that they are configured in the software. So you wouldn't want to plug a rotary knob into 2 and 3 because you couldn't tell it that 2 and 3 was a rotary knob. You have to start with the odd, then go the even. So what were we doing? 37 and 38. So now if we go to 37 and 38 over here, we can turn on the rotary knob by choosing one of these ratios. And the ratios, you have to mess with it and see what works for your system. What will happen is some of the hardware that you use, like your rotary knobs, are cheap, or maybe they're really nice, who knows, but you could click it once and it'll be such a fast click that it picks up more than one. I've found with the ones that I use that 1 to 2 works really great. And then the speed, also the pulse width. So like it can put a delay between when it accepts the next signal. So you can mess with this too if you're having problems with the timing, like one click gets too many signals in your game. Maybe your game is sensitive. I've had DCS is a little more sensitive than, say, Microsoft Flight Simulator. I've seen different things work different ways. So you might have to make it a little bit longer or shorter depending. I find with these rotary knobs that I bought that this is kind of a good setup, 1 to 2 and 48. So now if we go back over here and we look at button 37 and 38, I'll rotate it to the right, blink, one blink. One blink. That's one click on the rotary knob is getting one blink. If you turn it and notice it's blinking twice, then you may have to mess with your speeds over here, increase the ratio, or maybe reduce or increase the pulse width. And you just want to make sure you find a spot. See, there's two clicks, two clicks. I'm just rotate it fast. You can see it's click, 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 click. It's picking them up. And then the other way, one click, one click, one click, one click. There we go. So these are ready to go. So I'm just going to go ahead and turn on all of the things that are rotary knobs. I wrote them down as I wired them up, which spots I plug them into. So let me do that real quick. All right, I've gone ahead and set which ones were my rotary knobs, and now everything should be working. One click each. Every time I rotate, I should get one pulse, which is what is happening. So you're going to want to test yours, make sure everything is working and registering properly, and then your board will remember this. Through this, you can have to hit save or anything. It just remembers it. I'm not sure if it remembers it on another computer. That I don't know. I've never actually tested that. But that's configured the board, and you're ready to go in game, which we'll do next, and go ahead and start binding your buttons. All right, so now we're in game, and it's super simple at this point. Just go up to your settings, go to your controls, and you can see I have a ton of things in here. But you're going to look for the Bodnar BBI-64. There's ways to rename them. I haven't found a good way to rename the BBI-64s with the firmware. But either way, you just kind of have to go to the radios, and I'm on UI layer. Go to the radios and decide, let's see where the radio settings are. Here we go. And basically, I've already have them all programmed in. So like, the UHF selector, so forth. Like let's say I was going to go ahead and set the 10 increase. You basically just click here, rotate the button the way you want. See, I already have it set. Decrease, there we go. You just click it, move it, push it, whatever it might be, and then you choose that one, and you're good to go. That's how you bind your controls. You're ready to play. All right, I thought I'd show you how this works in game. Now that we're here, I'm zoomed on the radio panel. You can see my mouse is not being used, but if I move the dials over here, everything is good to go. I hope this helped you out. Let me know if you have any questions.